Before looking at example 1, let's look at this key concept box about rational numbers, which we learned about on our previous vocabulary page. So this little type of Venn diagram kind of shows a little bit of information about your numbers. So the numbers that you started learning when you were very little, called whole numbers, 1, 2, 3, all those good things, okay, those are considered whole numbers. Then, later in life, you learn that those whole numbers are included in a larger set, okay, along with other numbers like -10, -6, those negative things, and those are called integers. So the whole numbers and the negative numbers now, those are considered integers. Well, now we're learning that all those integers that we know are also considered in a larger category, which is called rational numbers, which are any number that can be written as a fraction. So all those whole numbers we learned can be written as a fraction, all the integers we've learned can be written as a fraction, and all these other things that are here, okay, or other examples, all of those can be written as a fraction as well, okay? So fractions, terminating and repeating decimals, percents, and integers, they're all rational numbers, and every rational number can be expressed as a decimal by dividing the numerator by the denominator. So we're going to see that in our examples. One thing you're going to see with repeating decimals is there's a certain way to write them. So you use what's called bar notation, okay, which puts a bar above the digits that are repeating. So in this example here, this is 0.54545454. But instead of having to write it out like that and write the dot dot dot, you use bar notation. So you just write the digits that are repeating and then place the bar over top of them. It's important that the bar is over all of the digits that are repeating. If you look at this example, 0.5833333333 and so on, okay? The 5 and the 8 don't repeat, but the 3 does. So when you write this in bar notation, you're going to have 583 thousandths with the bar above just the 3. Now let's take a look at example 1. To write 5/12 as a decimal, okay, I can't easily change it to an equivalent fraction that's got a denominator of 10, 100, or 1000, okay, to easily write it as a decimal. So I'm going to have to do division. We know that a fraction bar does mean division, okay, so I know that I can do 5 divided by 12 to change it to a decimal. One nice way to kind of always remember that, what I like to think, is that 5's on top there, and it falls off the roof and into the house of your division, okay? And then I usually add a decimal point and 2 zeros after it to start my division process because I know I'm going to be changing it to a decimal, so I need to put that decimal point there, and the 2 zeros I probably have to annex anyway. So then you can do this, which is what they've done here in this example. So then they've gone through and done this division. So 12 goes into 5 0 times. 12 goes into 50 4 times, which gives you 48. You subtract, you get 2. Bring down your next 0. 12 goes into 20 1 time. 1 times 12 is 12. You subtract, you get 8. Bring down the next 0. So you'll have to annex another 0 and bring it down. Now 12 goes into 80 6 times. 6 times 12 is 72. You subtract and get 8. Annex another 0, bring it down. You get 80 now. 12 goes into 80 6 times. Times 12, you get 72. You subtract, you get 8. And now you can kind of see this pattern happening. So you know that that 6 in your quotient is going to continue to repeat. So now, when you write this, okay, as your final answer, you don't want to write as many 6's as what you found in your division, okay? So it's kind of like writing your decimal in simplest form, and you only want to write the digit that repeats one time before putting the bar above it. So you would write it like this. So 416 thousandths with the bar above the 6. So this is an example of a repeating decimal. Try the got it problems on the top of the next page to check your understanding.